This video presents the final report of the BeaglePilot project, a project selected by BeagleBoard at the Google Summer of Code 2014. The project has been tutorized by Untitled. BeaglePilot aims to create a Linux-based autopilot for drones using the BeagleBone and the BeagleBone Black as the hardware blueprint. It also uses the Autopilot code. Here I'm presenting a summary of the week reports. A full report is available at this URL and can be checked. This full report included here contains a detailed update on every week progress. So you can always come here and check it yourself. Now, really briefly, during the community bonding period and the first weeks, some drivers were coded and tested. Week 4th, some real-time comparisons were performed mainly using the RT-preempt patched kernel, the Xenomai patched kernel, and a vanilla kernel. Then during weeks 5 till 9, some ROS Autopilot integration was done. Pretty much some already available packages were evaluated. The ROS integration is, it works, but probably might be needed to work a bit further on the, let's say, on the bridge. During weeks 9 till 11, some aspects with driver issues and tests were dealt with, and finally, some documentation and wrap up. The code is available at this repository. The work has mainly been focused on the AP HAL Linux, which is the layer of abstraction that basically allows the code to run in Linux. Here we have, for example, the SPI driver implementation for Linux. Apart from working in this AP HAL Linux, also the effort has been concentrated in creating some other drivers. For example, here under the AP inertial sensor or on AP Baro, etc. There's also a set of blog posts that can be reviewed at this URL. This blog post pretty much inform about the issues that I encountered during the weeks and how some issues were dealt with, etc. There's also a set of videos that illustrate the process, some tests, and pretty much the progress of the project. Most of the code has been already merged into Do-It-Yourself Drones Autopilot repository. This is the main repository of the Autopilot code, and I'd recommend you to check out this repository if you're planning to build on top of the work performed this summer of code. The documentation has been included in this Gitbook, available at this URL. Checking the Gitbook quickly, you can see that there's a section for Autopilot that includes a brief subsection on how to implement a simplified autopilot in Python. Now, this hasn't been used through the BeaglePilot project, but it might be useful for newcomers to this world of drones to see how actually an autopilot is implemented. The subsections of Autopilot cover different aspects, particularly putting some emphasis on the AP HAL and the AP HAL Linux. There's also a section on MapLink, and particularly interesting is the subsection on the ROS integration, covering 4 different packages. And there's also some other topics covered, such as, for example, map proxy and ROS. It might be worth it checking how to install ROS in Debian from source. All the process is documented here, and let's say the issues encountered in the way, etc., etc. Now, in summary, after having spent about the last 3 months working on this project, the results are the following. The drivers have imported and some new have encoded. The Pilot basic functionality has been ported to Linux, offering now the chance to work with APM Rover 2, Copter, or Plane on Linux. Also, some real-time kernel comparisons were performed at the beginning in the very first weeks that showed that actually the requirements were going to be met. It might be worth it though to spend some time redoing these comparisons now with a more mature version of the software. The autopilot's communication can be launched now through a TCP socket, which actually simplified substantially the development and the debugging of an autopilot. ROS is running, has been tested, and well, it's fully functional in a small Linux box, such as the BeagleBone Black. There's also documentation available, and finally, just mentioning that the hardware is still not fully ready. It's a work in progress, and hopefully, we will fix this soon, and well, offer a solution for everyone interested. Again, you can check the reports, the weekly reports on this URL. The hardware that has been used is mainly the Erle board, which is now actually converting itself into Erle board, which will allow to use this Linux autopilot, Linux hardware autopilot in different platforms, not just in copters, but also in planes, rovers, submarines, etc. Also, at the very end of the summer of code, I received the PixHawk. Unfortunately, not all the systems are yet working in the PixHawk, and well, this avoided me from making well tests in real scenarios with real drones. The next steps are probably starting to make the tests and well improving the software. I just built a rover, a really simple one as you can see, and well, I will use it for now until I receive more hardware and I can keep advancing. Well, these are the URLs, the main URLs of the project. There's much information. You can also read a lot about the topic on do I just have drones or on drones discuss in Google Groups. And well, just thank again to Beagleboard, LA Robotics, and 3D Robotics for their support. Also, a special mention on Andrew Tritchell, my tutor, which has been doing an amazing work with us, and I'm deeply glad that I had the chance to work with him. And well, that was pretty much it. It was a really exciting project. I'm really happy, and of course, I will continue supporting the project and developing for Linux autopilots.